and in this episode of Syvecs Says, we've been asked about PDUs. Hi, I'm Ed from Syvecs. I'm the Technical Operations Manager, and in this episode of Syvecs Says, we've been asked about PDUs. So what is a PDU? So in simple terms, it's one of these. This is a power distribution unit. It's the modern way we use in motorsport to control car electronics. High power electronics, so that might be fuel pumps, radiator fans, lighting on the vehicle, anything related to body electronics, that kind of thing. So why would you want to use one of these things? Firstly, in a traditional car wiring situation, manufacturer kind of thing, you'll have all your controls around the steering column, and everything there will have its individual wire from each switch, if you like, going to various areas around the car. There is a lot of cabling, there is a lot of things going on, and it will all go via a fuse box. Obviously that offers your electrical protection, and then onto the devices which all the switches control. This is all very well, but it's time consuming if you're making one of these in a one-off situation. So you have a race car, maybe even a race series. To create a loom like that takes a lot of work. One way to overcome this, or to assist, is by centralising everything to one area of the vehicle. So you can have, instead of multiple switches around your dash, you could have a kind of a keypad. I don't actually have one with me to hand, but that might be for your windscreen wipers, that could be for your ignition, anything that you need to control whilst using the car on a track. Quite often they have quite big buttons, so that if you're wearing your race gloves, and a positive feel, so that you can get that feedback from them. But they simply connect to a unit like this using CAN bus, and that allows you to remove all the wiring away from the dash to the location of where it's more suitable on the car. The other benefit with a unit like this is their flexibility. So these have the ability to also offer the protection for your electrical systems. You do not need a fuse box as well. So for example, in this unit we have the main power coming in here, and we've got various outputs and the I/O configuration on the unit itself. But on the high current outputs, let's say might control a fan, might control a fuel pump, you can define protection parameters to monitor what is going on. So for example, something happens and your rad fan is blocked and it can't spin. Traditionally that would blow a fuse. It may well be that for whatever reason, say a stone or something's caught in it, you'd hope not, because it's whatever, it stops the fan spinning. So that means the motor is drawing a high amount of current, and in a normal instance that would blow a fuse. What would happen in this case is you could define a current limit, which if it goes beyond for an X amount of time, that output is turned off. You can even tell it to reattempt the output. So if this output draws more current than it should do, give it a few seconds and try again. So that is quite a nice way of offering circuit protection. And the other thing as well is, should something like this fail, it allows it to communicate back over the CAN bus to an ECU to tell it that something's not right here, you might need to take other action. The other thing you can do, which is quite convenient, is you can join outputs together. So if you have a device that has more output current than one output pin can support, because quite often the power limitations aren't the electronics inside, it's the physical pins on the case of the ECU. There's only so much current they can take for so long, and in the cases of things like fuel pumps, they're on continuously, and that current over a period of time can cause pins to heat up and fail. So we have the ability to join pins together to increase the current carrying capability of the connector. What else can you do with them? You could have an output programmed to do your indicators, and you could then have a button that's all in the digital domain controlled, that turns the hazard lights on so that they all flash at the same time as you'd normally expect the hazard lights to work. You could have logic timed outputs for windscreen wipers, this kind of thing. You could have outputs that are controlled over CAN bus, where if your intake temperature raises too much, you could spray water onto your intercoolers. There's all sorts of things you can do with a PDU that makes a unit like this really great for optimizing your wiring on the car keeping the wiring short, and also making life easy from the point of view of installation. And there's also one other thing that's really quite an important thing to mention, is the fact that these also offer emergency cutout protection of facilities, in the sense that if you have an engine bay fire or if something goes wrong, both easily, internally and externally on the car, you can have an emergency stop button that turns off all the power to everything immediately without any worry or without any concerns of levers having to be pulled, and in some cases, things not working as intended. So they're an all-round good option for a situation where you need protection for your electronics, you need protection for you as a driver in whatever scenario you might be using them for. So check out our Syvecs PDU range. We do a few and various different kind of input and output configurations. They're all pretty easy to use once you've got your head around it. It's the different kind of logic states. Essentially, if I receive this input, do this output, that kind of thing. It's all very visual. Have a look. You can play with the software even. They're pretty good. If you found this video useful, give it a like. If you have any more questions about this or any of our other products, you can ask below. And why don't you subscribe to this and keep an eye out for the next one.